Hello there. This is the video that's all about. We're going to look at how you can construct a transformational matrix for the multiples of 30 or 45 degree rotationals. I'm going to go into some detail about this process. Our example is we're going to be doing a 120 degree counterclockwise rotation, but the process you can apply to anything. So first thing I'm going to do is label 2 points. I always pick the points 1, 0, and 0, 1. These points form my pre-image. And I'm going to list them out there, the 1, 0 first going vertically, and the 0, 1 second also going vertically. Now I'm going to try to figure out, under this 120 degree rotation, where does 1, 0 wind up getting mapped to? This would be 90, and then it keeps needing to go forward a bit. It's important to have a decent picture in this one. This is why I put the circle in beforehand, so you don't have to suffer through my hand-drawn circles. But if I put this green dot anywhere further, if I put it like here, the halfway point, that would actually be a 45 degree angle. I got to go 90 and then a 30 in for the 120. So it's about a third of the way along this arc. Getting a good picture means that I'm going to have a good triangle to look at, and I'm less likely to make mistakes based off of my pictures. Okay, so let's connect that. There's my arc of 120. That and there's a 90, so that's a 30, and I can frame a triangle. The shape right in there is a 30, 60, 90 triangle. I also happen to know that the hypotenuse of this 30, 60, 90 triangle is 1. This is why I had you memorize those the short and long lengths of the special triangles for 30, 60, 90, and 45, 45, 90, because I can use those to get the xy coordinates. The short length here is 1/2, the long length is √3/2, so the x-coordinate is I'm going backwards that 1/2, -1/2, and then I'm going up √3/2 for the y. This is simply where the point 1, 0 got mapped to under this 120 degree counterclockwise rotation. So here we have the pre-image. I'm going to create the image matrix. 1, 0 gets mapped over here, and I need to write these coordinates vertically. So that's the first one. Now I need to do it again for this point up here, 0, 1. Again, I have a 30, 60, 90 triangle. For the x-coordinate, I am going back √3/2. And for the y, I am going down 1/2. And this is where the point 0, 1, right up here, got mapped to after 120 degrees. So I write those coordinates vertically for the image. Now I'm going to go into some detail on this next part here. I'm trying to figure out how this pre-image gets mapped over here. So with the matrix multiplication, the transformation matrix is over here on the left. So I'm applying some, it's going to be a 2x2, mystery transformation, 120 degree counterclockwise rotation to this pair of points that maps it over here. And I ponder and ponder and ponder and try to figure out what are the entries in this matrix going to be, and then the scales fall from my eyes. This is the identity matrix. So my mystery matrix over here has to be the same as that one there. Identity matrix, you multiply by it, you get yourself. And there we go. That's my 120 degree rotational matrix right there. So notice that actually we had it way up here at this point when we just figured out where the image of 1, 0 went to, the image of 0, 1. But this argument here was just to back up why this process works. You always look at where 1, 0 goes to, where 0, 1 goes to. Character and scholarship for life.